Now we're going to have an overview of the casting technologies. So the casting is usually performed in a foundry. So the place where we're going to do the casting process at is going to be called the factory, which is a factory which is going to be equipped for the first making of the molds. Second is going to melting and handling the molten metals. Third is going to be performing the casting process. Fourth is going to have the cleaning and the finish of the casting. The worker who perform the casting are called the foundryman. A single is going to be foundryman, of course. And the mold in the casting is contain a cavity whose geometry determines the part shape. The actual size and the shape of the cavity must be slightly enlarged, and this to allow for the shrinking of the metal during the solidification and the cooling. So for example, the final size of the part I would like to have is going to be 1 cubic meter, just an example, and thus I have to fill the cavity with the molten metal with, let's say, 1.05 cubic meter, and thus when it's going to have the shrinkage process to occur, the final size I'm going to have is going to be as close as possible to the 1 cubic meter, and that's what we call the oversizing. The molds are made of a variety of the materials. For example, it can be made of the sand, which is the eldest method we can have for the casting process. We can use the plaster, we can use the ceramic, and we can use the metal, and this will depend on the technology we're going to use for the casting process. Now, also we can classify the casting into an open mold and a closed mold. So these are the two forms of the molds. On the left side, we can see the old shape of, the old technology for the casting, which was the open mold casting. It doesn't have cavities, but the shape we are going to have is going to have a block shape, which is going to be open from the top, and in all the cases we have to clean this area. And the other shape on the right side is showing the closed mold for more complex mold geometries with the gating system is going to occur, and also we can have the razor, as you can see here. So the core, it does have it's going to be included within the cavity, and this core is going to be useful to generate the holes, for example, within the casted part. So the two categories also for the casting process can be the expandable mold processes, where the mold is going to be sacrificed to remove the part. The advantage of this category is that more complex shapes are going to be possible, because simply if I'm going to destroy the mold, I'm going to leave the cavities which are going to generate the part itself. The disadvantage is that the production rate often is going to be limited by the time to make the mold rather than casting itself. So you may take, for example, 2 hours just to make the sand casting mold. You're going to do the process of the casting in 10 or 15 minutes. So this is the main disadvantage for the process. For the permanent mold processes, where the mold is going to be made of metals and it can be used to make many casting at the same time. Time in the production, the lifetime of the mold. So the advantage of this one, we're going to have higher production rate, because the same mold is going to be filled and emptied multiple times. But it still has this advantage where the geometry is usually going to be limited by the need to open the mold. Now we don't want to sacrifice the mold. It's not going to be sand I'm going to destroy after do the casting process. I need just to open the mold. This can be 2 or 3 parts, and take the parts from the core. So in the sand casting mold, that's the shape we are going to have. The mold is going to consist of 2 halves. The upper side, as you can see, is going to be called the cob. Now you can see the third word from the top on the right side is the cob. The cob is the upper side of the mold. The drag is the bottom half of the mold. In between them, we are going to have the parting line. The mold halves also contained in a box, and this box is called the flask. The two halves are separated within the parting line. So forming the mold cavity in the sand casting, the mold cavity is formed by packing the sand around the pattern, which has the shape of the part we would like to have. When the pattern is going to be removed, the remaining cavity of the packed sands has desired shape of the casted part. The pattern is usually going to be oversized, as we mentioned earlier, to allow for the shrinking of the metal during the solidification and the cooling process. And the sand for the mold is usually going to be moist and contain a binder material to maintain the shape. The use of the core in the cavity of the mold cavity provides the external surface of the casted part. But in addition, the casting may have an internal surfaces determined by the core placed inside the mold cavity to define the interior geometry of the part. And in the sand casting, the cores are generally made of sand, and this is an example of the pattern we can use for the sand casting processes. So as you can see on the right side of the left photo, this is the pattern which has been made from wood. This is the induction for the car engine. And on the right side, on the left side, we can see the casted part. Now you can see here that we are going to make the external shape. How we are going to get these holes? How we can get the cavities inside the casted part? We can put the core. Now this is one of the other example. We can make the pattern made of wood, and we can get the casted part. This is one of the processes to make the pattern for the centrifugal pump casing. The gating system is very important in the sand casting, which is going to be the channel through which the molten metals is going to flow into the cavity from the outside of the mold. And the gating system consists of the downspur through which the metal enters the runner leading to the main cavity. At the top of the downspur, the pouring cup is often going to be used to minimize the splash and the troubleness as the metal is going to flow into the downspur. The riser is a reservoir in the mold which is going to be a source of the liquid metal to compensate for the shrinkage of the part during the solidification. And this riser must be designed to freeze after the main casting in order to satisfy the function. The heating in the metal, I'm going to make this one another part.